Assessing the resilience of your workloads in Azure is key to running mission-critical services. Today we're going to take a look at how to assess whether you're making use of the resilience capabilities of the cloud for your workload, from some theory to consideration through to how to run your own well-architected resiliency assessment. So, for those who don't know me, my name is Luke Murray. I'm the Infrastructure Security and Modern Workplace Lead at HSO, Microsoft Learn expert, and a Microsoft Azure MVP based in Hamilton, New Zealand. Feel free to reach out, connect, subscribe, send me a message or a question if you've got anything that you want to learn more about or you have a question about. I'm here to really help. So this session is part of the Azure Back to School event. So Azure Back to School is an annual community event featuring IT professionals from across the world. You can go to azurebacktoschool.com. Lots of great sessions, topics ranging from data and AI to sessions like this, resiliency, anything you can really do and consider when thinking about architecting and building on Azure. So lots of great stuff by some amazing speakers and definitely something to learn from everyone. So let us set the scene. Before going into some considerations on the resiliency of your workload, I want to just take a step back into why bad things happen. So it's a simple question, but at the core of everything you do in technology, no matter how much planning, testing, reviewing we do, things do go wrong. And the reason is because of three fundamental truths. One is hardware will fail. It's just physics, right? So servers, disks, networks are all physical, and physical things break. So that's why we design with redundancy in mind. So when one piece of hardware fails, another piece is ready to take over without customers and consumers even noticing. Second is software will have bugs. So even the most carefully written code can have unintended side effects. That's why we just don't deploy code blindly. Instead, we deploy cautiously using safe deployment practices and monitoring so that when something does go wrong, we minimize the impact of that change. And third, people make mistakes. So none of us are perfect, and human error is one of the most biggest contributors to outages and incidents. We can reduce that risk by automating repetitive and error-prone tasks, removing people from the critical paths where it makes sense, and freeing them up to be more time on focus on innovation instead of firefighting. I've been guilty of this one myself, unfortunately. Sometimes the best laid plans can lead to something just not going right or something breaking. And we'll talk more about that very shortly. So when we do ask ourselves, why do bad things happen? It's not about avoiding the inevitable, but it's just about preparing for it. So let's delve a bit more into that. So this model is often called the Swiss cheese model of failure, which shows us why accidents can happen, even when we have defenses in place. So each layer you see here represents a defense. So institutions, organizations, professions, teams, individuals, and even the technology. These are all our safeguards, but no defense in this chain is perfect. Every layer has holes, gaps in processes, policies, behaviors. Maybe an institution might have incomplete procedures. Maybe within an organization, mixed messages or production pressures can create cracks. I'm sure we've all seen it. At the team level, responsibility shifting or inadequate training can open gaps. And for individuals, distractions or fatigue can play a role. And of course, technology has its own holes, clumsy tools, coding bugs, or deferred maintenance. So most of the time, these holes don't line up. One layer stops the problem before it reaches the next. But every now and again, the holes do align, and that's when accidents slips right through all our defenses and something breaks, and resiliency is a core concern. So by strengthening each layer, closing gaps and learning from our mistakes, we can reduce the chances of those holes lining up and prevent bad things from becoming disasters. Today's session is more aligned to the technical layer in regards to what can the Azure platform and the services surrounding that can help us with. However, I just want to make the point that resiliency is a lot more than just enabling a checkbox. You have to consider the people process around all the technology and the products that you deploy as well. So if we consider the resiliency nature of the Azure platform, there's joint responsibility of it with Microsoft and yourself with your own workload. So as a hyperscale provider, Microsoft are responsible for the various aspects of supplying you the infrastructure and the platform services to run your workloads. Microsoft are responsible for the physical layer that your services are running, from the nodes and the racks through to the data centers, the regions and network connectivity themselves. But you as a consumer of the platform are responsible for your application and workload architecture. You're responsible for utilizing the resilient services that are on offer and using services such as load balancing, high availability, architecture design, application pattern considerations, such as utilizing patterns such as circuit breaker, deployment stamps, or bulkhead patterns in your workload design to prevent outages. Your responsibility is where technical strategy comes into play and making informed decisions around how your workloads are architected based on the business requirements of your applications. In an ideal world, you would know the criticality of the workload even before something's created on the Azure platform, as the business requirements dictate what services you use, overall architecture and cost of that solution based on the value and assumptions from the people actually using it. Now, this is the reliability in the cloud for you as the consumer. So let us break down a bit more into how the Microsoft Azure platform itself has redundancy out of the box. So each Azure geography is comprised of one or more Azure regions that sit within a fixed data residency boundary. So in each geography we have at least one region equipped with availability zones. If we look geographically at such as New Zealand, we have a data residency boundary of New Zealand. In each geography we have at least one region with availability zones. So within that geography is a region. So this region is a collection of one or more availability zones. Common architecture is 3 availability zones that consists of one or more data centers each. So this architecture is classified as 3+0 architecture. So 3 availability zones, a zone or another region of your choosing as needed by your workloads. Each Azure region is comprised of one or more data centers that sit within a fixed metro level boundary. So usually a single city. So in New Zealand that's Auckland. So it's within a latency defined perimeter of less than 2 milliseconds between each availability zones, allowing synchronous data replication between them. Older regions have paired regions such as Australia East, so when you go and enable geo-redundant services and replication, that will replicate to a predefined region. So for example, if you're in Australia East, you enable GRS on a workload, that predefined region will be Australia Southeast, already pre-selected for you. This is kind of an older concept. Paired regions are an older concept. With new services now allow you to specify what regions you actually want to make use of. For example, New Zealand North could replicate to Australia East, or even it could replicate to the US. So it's up to you as a consumer to to figure out whether or not you actually need GRS replication and what region you want to make use of that as well. So the flexibility from paired regions to be able to pre-select, or not pre-select, but select your own region if at all you need that capability, is up to you to make use of. Then within the region itself, we've got availability zones. So we've touched on them a bit, but availability zones is a logical boundary of one or more physical data centers. So modern regions require availability zones, 3 separate, physically separate zones, and there are still regions out there that may have 1 or 2 availability zones, but they are getting uplifted as we speak to the full 3. So there might be other regions out there. Australia Southeast comes to mind, where there may not have 3 complete availability zones at the moment. However, there is work happening to get these all uplifted to be a full 3. So that goes back to the 3+0 architecture, 3 availability zones plus whatever else you need. So they are becoming less and less often of having regions with less than 3 availability zones. So each availability zone is designed to be backed by independent power, cooling, and networking. So now we've discussed resiliency and some of the Azure platform capabilities, and that resiliency is a shared responsibility, and it is a multi-layered concept as well. Let's dig into some of the capability or considerations that we have when architecting on the Azure platform for some of our workloads. So one of the first things we could consider when we're architecting for one of our workloads is, does it need to be active passive? So in this scenario, we're looking at like a virtual machine workload with ZRS, so that's zone redundant storage. So zone redundant storage synchronously replicates data across all 3 of those availability zones, ensuring high durability. So in the case of an Azure availability zone failure, the disk still remains accessible from another zone. This works well for workloads that might be sharing a single data disk across multiple zones, or workloads such as failover clusters that have an application component spread across 2 or more virtual machines. And if a zone fails, it will immediately fail over the application workload to a secondary node, continuing to run. It's also worth noting that most PaaS, so Platform as a Service resources, if not all of them, have ZRS functionality out of the box, and it's just a matter of enabling it. The failover components are managed by Microsoft in this case. The second sort of architecture we might look at is active-passive. So in this example, it's active-passive deployment using Azure Site Recovery. So Azure Site Recovery brings disaster recovery protection for virtual machines using locally redundant disks and Azure availability zones with zone-to-zone disaster recovery. So if one zone fails, it will automatically spin up a VM in the secondary availability zone or region if that's what you want. Another concept is active-active deployment architecture. So this is when you're using something like a virtual machine scale set, which consists of similar or identical virtual machines with separate disks spread across multiple availability zones with a load balancer in front. In this example, this is a website being hosted across multiple machines, but sharing the same backend SQL database, which could be a platform as a service database that is already zone redundant. So users will hit an application gateway, which then sends the traffic to a working virtual machine in zone 2. Once the zone 1 virtual machine comes back online, the application gateway can then redirect traffic to the now working VM and you can spread the load between like both the virtual machines, keeping it redundant, and the workload more performance, because it's not just hitting the one working VM. It's now as a user, you might be hitting VM1 in availability zone 1 and then VM2 in availability zone 2. So requests can then get spread between multiple workloads as well. I know of a particular workload that uses this pattern in production. It does data transformation of data that goes into Microsoft Sentinel. So it would sit on a Linux-based virtual machine, and because of the criticality of the workload, you would have multiple virtual machines spread across all 3 zones. And then an Azure load balancer would sit in front of it, and then the load balancer is able to redirect traffic between those 3 VMs. This architecture also mimics what most platform as a service offerings actually are. So the resources, for example, a SQL database, are active across all 3 zones, and you're just hitting a load balancer, redirecting you to the closest or healthiest one. So we've taken a look at some of the common infrastructure patterns for workload resiliency, but it always comes back to what are the business requirements. So not all workloads are equal. Ask yourself, how critical is that workload? Is it actually resilient, or does it even need to be? If it is resilient, how can I keep it compliant? What are the manual processes or automation to fail over your workload in case something does happen? Let's go in and define what a workload actually is. So a workload is a collection of application resources, data, supporting infrastructure that functions together towards a defined business goal. It's usually not a single resource, but a collection of resources from compute through to a database or a cache that makes up your workload. A real-world scenario could be a production tracking system, which uses an application tier and data tier services and depend on shared services within the environment. The customer could group the Azure resources for the workloads and its dependency within one or more subscriptions. It's worth noting in this case, there is a new management group concept in public preview at the moment being released by Microsoft called service groups. So they'll help a lot in defining your workload within an environment. So although it's out of scope of this particular video, I've done videos and blog articles on it, so make sure you look that up along with read the official documentation about service groups in general. It's going to be a key concept and capability going forward when looking at things like your workload and how you sort of move away from more of that technical thinking to that more business orientated thinking about what are the shared resources that your workloads depend on. So now that we know some of the platform resilience capabilities, some of the architecture patterns, and how to actually define what our workload actually is it actually mission critical? As with the well-architected framework pillars, there's a push and pull and trade-offs between them. For example, cost optimization may pull against performance pillar because the more performance that your application or your workload needs, it may need higher SKU of resources. It may need to scale out to more than one. So already you have to balance the performance of that workload with the cost of that workload as well. It's the same thing with reliability. So the more mission critical your workload is, the more redundant it needs to be. For example, does it need to be active across 2 regions, for example? So defining the characteristics of your workloads helps define the business and social impacts of your workload and the cost and complexity needed to run that workload. It's worth noting that none of this is new in the cloud. These are the same considerations that you need to make when designing any workload, whether it's for Azure or on-premises. Most common ways of looking at the complexity, cost, and business criticality is to tier them. For example, if we take a look at Tier 1 mission critical workloads, this could be across a single cloud region or multiple clouds and regions, and maybe active or active in one region with a warm standby that can take over at any moment in another. This may need synchronous replication and service and health model monitoring. In comparison, if we look at something like a more Tier 4 administrative app, it may only need to run on a single or more than one availability zone. It doesn't need to be active. Restoring from backup is acceptable. It may need some request throttling just to avoid it being unperformant, but you're happy with rolling upgrades that might impact the service for a minute or so during an upgrade. Guidance and tiering helps you wrap around operational support, relevant architecture, and the cost of the service that supplies value to your business unit. So really ask yourself, okay, we're running this workload. What are the elements that we actually need to be based on the business requirements? Does it need to be resilient? Also, something to keep in mind is even if one component is resilient and another component isn't resilient, you need to be aware of that as well. And that's where the next step comes into play, which is the well-architected reliability assessment. So now that we've assessed some of our workloads, it's time to evaluate the reliability of our workload. So in my walkthrough, I'm going to go through the WARA, or the well-architected reliability assessment of a tolls booth workload. So the workload I will be reviewing is a toll booth demo application. So this application is designed to demonstrate Azure serverless technologies. The demo will showcase kind of the architecture of different services being used and how we can measure sort of the reliability of those services. So in this case, the toll booths application is there to really process vehicle photos, extract license plate data, and store them in a NoSQL data store in Cosmos database. So this demo application was actually created by a Microsoft certified trainer, Rob. So definitely shout out to Rob. This is a great application in order for me to test and run through with you, because it uses multiple different services that commonly are used when designing applications and workloads within Azure. So the well-architected reliability assessment is aimed to assess an Azure workload implementation across the reliability of the Microsoft Azure well-architected framework. So as we've discussed, a workload is a resource or a collection of resources that provide end-to-end functionality to one or more clients. So the clients could also be humans or systems. An application can have multiple workloads with multiple APIs and databases working together to deliver specific functionality. The main goal of the well-architected reliability assessment is to provide an in-depth and comprehensive end-to-end architecture and resources review of an existing workload to identify critical reliability, resiliency, availability, and recovery risks to a scoped workload on Azure. So this is going to be using the WARA PowerShell module that's part of the Microsoft well-architected reliability assessment engagement. So this is commonly delivered by Microsoft Cloud Solution Architects, for example. This, using the PowerShell WARA module, you can actually go through and run this across your own workload estate. So I'm going to give you an overview very shortly of going through the toll booth application and how we can start collecting the data. Then we analyze that data and then report on that data as well. So as we talked about, the WARA script is essentially a PowerShell module. So you can find this in the Azure Proactive Resiliency library. So this is a great resource, just GitHub pages that you can access to view the resiliency guidance around some of your workloads. So this supplements what's in the Azure well-architected framework by giving you a bit more actionable guidance. So for example, we can go in here and we can go, okay, let's have a look at the Azure resources and say we wanted a review of some of the guidance around container apps, for example. We can go in here and we can click on container apps and we can see some of the resiliency guidance is actually enable your container health probes. So we can see here that like the impact is low if you don't enable it. This is very subjective as well. It all depends again on your business criticality workload and how you're using it. But we can see here that the description for this particular advice is enable container health probes to monitor the health of your container apps and ensure that the unhealthy containers are restarted automatically. So we want to be able to give the ability for the container app service to determine whether or not our containers are healthy or not. And in order to do that, we need to enable a health probe. So we can learn more about it by clicking this, and that will take us to the Microsoft Learn documentation. Or we can actually, in this case, we can have a look at a resource graph query, which will allow us to run a query within Azure to see whether or not we've got this enabled. In this case, there's no Azure resource graph query available, but for example, if we go into, I don't know, something else like a container registry, we're using a premium tier for critical production workloads. Let's take a look at this, and yes, luck be with me, but this one actually does have a Azure resource graph query as well that we can run within the context of our Azure environment to find all container registries that are not using the premium tier. So we can see the KQL where it's essentially looking up the resources, where the type is container registry and the SKU is not equal to premium. And then there's some more information around as well around the recommendation ID, and then outputting the tags and the ID and the SKU name, for example, and then ordering it by ascending. But there's a lot of great guidance here, and then more specialized workloads as well. So artificial intelligence, Azure Virtual Desktop, Oracle database, and SAP on Azure. So these are more around, instead of looking at your resource specific guidance, this is more around patterns or specialized workloads. So in order to run the well-architected resiliency assessment, we can click on the tools, and this will give us the information around the WARA PowerShell module. So in this example, there was a release actually in April of this year that has updated the tooling. So if you've looked at previous guidance on the well-architected resilience earlier than April this year, it has changed. So I personally have done a blog about this a year or two ago. The guidance has changed, so there's a new PowerShell module to do that instead of, it was a bunch of scripts essentially before. So the Microsoft team have done a really good job at bringing in a lot more information, especially from Microsoft Graph, and then consolidating within the PowerShell module. So we will go through the collector, the analyzer, and the report. So the collector will go through and run through a bunch of KQL queries with Azure Resource Graph, bring in a lot of the information that we'll need to do our assessment automatically before we need to go any further. The best thing about this is it's up to date with the latest best practice guidance. We don't need to go into every single resource and have a look at is zone redundancy enabled on our resource, yes or no. This will bring in the amount of knowledge that it can be from those particular resources that you're looking at. And then you can run this within either a cloud shell or your local machine as well. So to install the module, it's install-module WARA, and then you can import it. Then we can start the collection of it. In this case, it's everything within a single subscription. It will bring in classified as a workload, and then it will create a JSON file, which we can then analyze. And once that analyzation has occurred, it will spit out Excel file, and then that Excel file can then be used to generate the Excel and PowerPoint presentations that we may necessarily want to use to showcase to our management that we need to invest time in order to work on the resiliency of our applications. I've already got WARA installed, but let's import it. So import module WARA. This allows the commandlets access to PowerShell access to the commandlet. So for example, now we can start WARA collector and it automatically can pick that up. So what I'm going to do is start the WARA collector on my tenant and my workload, so the whole birth application that I ran through earlier is scoped into a specific resource group. So I did display briefly the documentation on the website. So they had start WARA collector, tenant ID, and then subscription IDs. So that could be one or more subscriptions that you're connecting through. In this case, I'm scoping it at the resource group level, so it could be one or more resource groups that are in one or more subscriptions. So in this case, for my demo purposes, I've simply got one subscription with one resource group, and that's my whole birth workload. So what I'm going to do here is I'm going to start the collector. It will check the version, so if you have installed the WARA module earlier, it will check the version to see if it's up to date. And now it's running the Azure Resource Graph queries that we need on our supported resources that I was talking about earlier. And then getting the proactive library recommendations as well. So just like I showed you on the website, there was a lot of recommendations for every specific resource type. So again, it grabbed that out. So once we've got that, we've got the JSON file now. So let's just see if we can have a look at what that looks like. So that is a JSON file with a list of the queries that it's ran, the resource type. So in this example, this is an app service. The recommendations it has is that the instance count for this particular one is less than 2, so that's not resilient in this case, because usually, like, if you have one instance, then it means if that fails, it's not able to continue running, as an example. But you can kind of see the raw data that this is bringing back. So once we've done that, we want to start the collection of that. So let's start the analyzer. So start WARA analyzer. We're going to give it the JSON file, and in this case it is the WARA, just ignore me, I should have copied it, WARA file JSON. So that's the file that was just given to us. So we want to start analyzing that. So let's just remove that. So we could see we've collected the data. So this could be hosted, or you could run this in a cloud shell. Then you can download, or another computer. Then you can download the JSON file, and then the analyzer could be done on another computer. So for example, if you've got access to an Azure environment that's that requires an admin, like an Azure Virtual Desktop machine, or a POR, so Privileged Access Workstation, you could use that to grab the JSON file. Then that JSON file you could copy or move to a workspace or your own computer, where you can then run the analyzer and then create the report. So in this case, it's installed the import Excel PowerShell module, so it will do it automatically if you don't already have it installed. And it's ran some analysis of the data that's already been collected, so that JSON file, and it's created a new Excel document for us. So we're just going to run this. And what we get is the well-architected reliability assessment expert analysis page. So this is where you start to analyze the data it's being brought in, and then specify a bit more business context around what your workload is, and also really tailor the response, because this is the file that will be used as a source to create the final report and the PowerPoint presentation you will use. So it's arranged in a couple of different sheets here. So if we go into workload information, we can see that it's asking for things like workload name. So in this case, it's going to be toll booth. Azure Cloud, it's going to be commercial. The primary region in this case is going to be Australia East. I've already filled out and got one already predefined, but I just wanted to show you sort of the information that it's asking for. What is the SLA? What is the RPO and the RTO? What are the challenges and the pain points that you may already know about this solution? Now is the place, and this is the place to capture it. What has been picked up as part of the collector? So in this case, for the toll booth application, we've got an event grid, we've got storage account, we've got our server farm, so our app services, and the website that's running on it. We've got a key vault, we've got cognitive services, for example, application, we've got some application insights and some action groups. So this is what makes up our toll booth application. We can see where it's being deployed to, and the resource group and everything in there. So, and then analysis planning. So automatically by the system, we have 23 services that have already been reviewed as an example, and then 63 are pending. What I mean by that is particularly not so much the Azure resources themselves. So as you can see here, there is definitely not 63 pending resources here. It's more around the recommendations. So instead of Azure resources, it should really be Azure recommendation. Then platform issues, and then it will also bring in any support requests if you've got any open for that as well. So you would go through here, you would specify an owner. So for example, we have a recommendation for cognitive services, and the owner of that is Luke Murray. I would specify that he is the owner for that. Any notes, you don't need to adjust anything in the assessment status here. That will be in the next pane. So if we go into impacted resources, what we can see here is the level of detail that we do need to go through in order to fully understand the resilience of our workload. So for example, there's a recommendation here on the event grid topic that says, diagnostic settings for all Azure event grid resources is not enabled. It's recommending to enable them. Or event grid does not deliver an event within a specific time. So because dead letter is not configured, for example. So we could see a couple of recommendations here. What we can do here is we can go through and review the recommendations. So this requires some effort by the application owner based on who you've specified here. So the assessment owners need to go through the impacted resources and evaluate them. Is it fit for purpose? So if the recommendation is irrelevant, then you can right click and delete these rows. If it needs to be, if for example we go, okay, well we actually do need to configure dead letter, we would go in here and we would specify, okay, it's being reviewed. So reviewed means we need to consider it. So we would go through every one of these recommendations, and as we can see here, pending, high to medium, recommendations which are needed. We can see these drop from 45 to 44, for example. So once all pending, high, medium recommendations have been reviewed or deleted, we can then proceed to the next step, which is generate the report. If we've got any platform resources, this is when you would sort of add in information about that here, like the event source, what information it's being collected from, anything that may have impacted, for example, at a platform level. The same for support requests. If you've got nothing, just right click, delete, right click, delete, as an example. So what I have here is, if I just close this and don't save that, we will open up something I've created earlier. So this gives you an example of, I've already filled out one that I've leveraged. So for example, I've got my information here. It's supposed to be an active architecture. It's in Australia East. The secondary DR is in Australia East. And my top one challenge has really been services are being deployed at different times by different people. So it's led to inconsistent deployment. One part may be resilient, another part may not be. We can go in here and we can see more like inventory is exact same, the analysis, planning. So in my case, I've reviewed all of them. There's no support requests or platform issues. I've gone through my impacted resources. There's no pending and medium. I've reviewed each one and been across that. So once you've filled out that and saved that expert analysis, the next step is to go a step further, and this is when we run our report. So in this case, we can start WARA report, expert analysis file, and then I'm going to give you the one that I've already completed because it's already got everything filled out. So it's in a completed folder, so expert analysis v1. So let's run that. So what that's doing is it's importing the import Excel, processing and running it within the Office app to generate Excel and PowerPoint presentation for me. It's also worth noting that at this stage you cannot have clipboard history turned on. I ran into this issue where if clipboard history is turned on, then you will need to turn it off. So what you can do is just go into the settings for your clipboard and then just turn it off, run the report, and then turn it back on afterwards as well. It's now created our report for us. So let's take a look. So let's have a look at this findings report. So this is the Excel file that's automatically be generated for us. So we can see instead of our workbook where we have to go in and review each thing, we've automatically got sort of the high, medium, low recommendations and the impacted resources as well. So we can go in here, we can see, actually our highest is really with application sorry and our workspaces and our Cosmos database, for example, and then followed by our super farm. So this is the high. The lows are really around like event grid system topics, and the same for our governance. So our highs are really around the high availability, where our lows are around more personalized or scalability guidance, for example. So it gives you a good visual view of kind of what you're looking at a high level. Then you can go into the recommendations. So this is the level of detail around, let's just sort this. So for example, our high recommendations around using application insights to monitor our apps, which is missing on our function apps by the looks of it. we don't have availability zones enabled for our Cosmos database. So this is where we would go in and we go, okay, well, we've got impacted resources, and these are the more specific guidance around that. So this is definitely something that you would be using for your app, for your technical teams in order to enable it. And then more information as well about kind of the resources that have been scoped in here. And then this is where you can adjust some pivot tables if you want to. But I quite like the fact that we can go in here and we can see the recommendations. We can know exactly what the resources are that's getting impacted, and the recommendations as well, following by the supporting Microsoft Loan documentation. So this file is more around what you would use from a technical lens. If we have a look at what has been created from more of something that you would show for your management, as an example, we would run the PowerPoint presentation. So this should load, and it has not loaded for me. Luckily, I will open it up. Yep. So here we've got our well-architected reliability assessment template. So this is essentially already been filled out for us in some respects. So you would type in the customer name, the workload name, the presenter information, for example. There's a few slides around the introduction, like for example this one, you've already seen me present about it as part of this session, but now you can see where I've got the Swiss cheese slide from. Information here around, okay, well, what was assessed? So what was assessed was around the workload design, the business targets for this assessment, workload summary. So in this example, 3 Azure functions or sites. We've got 1 database, 1 cognitive services. So that information has been brought in automatically from the graph. And then we would then put in sort of more information about what we found as part of the assessment. Information around kind of what is the availability in zone, region, resiliency, is the express route multi-site? Are there any service health alerts, for example, if something were to happen in availability zone 1 of a region, will we get notified for that? So there's basic things here where it does require human input in order to figure out and add in, but a lot of the other things like the recommendations dashboard has been automatically modified by the start WARA report PowerShell commandlet, where we can see that our Azure resources guidance has been put here, and we've got 50 recommendations in total and 16 impacted resources, and then we can add in some information about the well-architected framework automatically, so that we can view the sort of the dashboard information as well, and then sort of we could go in then to go, okay, well, let's add some more specific things around the express route resiliency and the workload resiliency, anything about service health, for example. And then this is automatically being sort of modified, so imported based on the resource discovery as well, about some of the high impact issues that we would be working to remediate. Again, this goes back to the exact same data set that we looked at with the Excel file, but this is just a bit more user friendly, especially if you were sharing this with a customer or your managers, and then you can add in some more information about kind of, have there been any Microsoft outages, for example, that have impacted anything, that service retirements that may impact our workload as well, and then information about sort of some next steps and Azure Advisor recommendations as well. So if we take a look at something that I've completed, we can kind of see this is what it would potentially look like after it's been completed. So we've got the, the reliability assessment exec summary, so that's Luke Murray. It's the toll booth application, our BOF application by the looks of that. We're going through the same thing of introduction, exec summary, haven't changed this at all, but you could if you want. What was assessed, so in this case, it's the workload name or the whole birth application. These are the resources that this workload depends on, and then I've chucked in an architecture diagram of that workload as well. So what was already in place, so in this case, login analytics data is being exported to GRS, for example. So you would add in what's going well, what's already in place for that workload. In this case, was the tollbooth application zone redundant? No, it wasn't. Is the express route protected against multiple peering applications? It's not applicable in this case. And no, service health alerts were not enabled for any of my resources, so I wouldn't have known. Recommendations as well, so create separate app service plans for production. The key issues really were lack of diagnostic settings, or insufficient instance counts, or absence of structured tested disaster recovery plans, and no self-healing as well. So this goes a lot back to, okay, not only do I need to make use of the technical capabilities of the Azure platform, but I've got some institute and some team people and processes that I need to work through as well. Is it documented on how I would recover from an outage, yes or no? These are the things that you kind of consider as part of that, and self-healing as well. So and then again back at the word risk and health, and then some more information going back there about sort of the health of the environment. From a technical lens, the assessment finding report is key. Quickly going, having a look at the recommendations, read up about why that would be the case. There's going to be recommendations where, for example, you may not want like separate web apps for web APIs, in which case you can ignore them. It goes back to the expert analysis documentation as well, and going, actually, for example, we don't care about defining reliability or recovery targets. It's a really bad example that I picked there, because the whole thing is about actually we need to define those. But if I was to make a decision that no, for this particular workload, we would delete that, and then that would stop it from getting delivered as part of the assessment finding of the report and the summary. But hopefully that's been of use to you and you've learnt something very impactful. The WARA PowerShell commandlet, very, very useful to have. You can scope it to a single resource group with multiple resources, multiple subscriptions, resource groups across multiple subscriptions. Collect the data, have a look at it, then you can start the analyzer and then create the report, all free. Just make sure you go to the Azure Proactive Library. So that can be found at azure.github.io/azure-proactive-resiliency-library-v2, and that will bring you to this page. Definitely well worth a look when architecting your resources on Azure. For the WARA, go to the tools and you can have a look at the Collect Data Analyzer and the reports documentation as well. So if you've run into issues, you can always have a look at the frequently asked questions. These are the dependencies and the requirements it needs. So PowerShell 7.4, as I already alluded to, it's using the import Excel PowerShell module, but if you don't have it, it will go and install it. And you need at least writer reader access in order to download and evaluate those resources as well. So definitely check it out. And yeah, hopefully you'll have a lot of fun making your resources more resilient in Azure. Let me know how you get on. Hope you've learned something. Thank you for sticking with me today, and yeah, have fun. Let's go and build stuff.